Okay, we're going to work on Unit 10 factoring. First thing I got to do, I hope you are knowing that I'm going to do this. I'm about to write something very large right here, and it deals with factoring. Can you guess what it is? All right, here we go. That's a lot larger than I thought, but that says GCF. All right, so remember, I spent a lot of time saying, hey, look for a GCF on the problems. It doesn't always happen, but look for them. So here we go. There is a GCF. 18 and 6, there is a number that goes into both of those. It's actually 6, so I'm going to take out a 6. Okay, the 6 comes out. X squared and x. I can take out as many as possible, but I have to take out the same amount of each. So that's an x. Y and y squared, I can take a y out. So moving in here, 6xy, and then what we have is, let's see, 3, because 6 times 3 is 18. We're missing an x, because x times x is x squared, and the y is good, so we're going to put a plus here. 6 times the number 1 is actually 6. X times 1 is x. Y, we are only missing a y on the back end there. There's nothing more I can do in here, so that is done. Pulling out a GCF and done. If you look at the numbers 12, 48, and 6, we actually do have a number that we can take out of each of those, and that number is, again, 6. So I'm going to take a 6 out. X squared, x squared. I can only take one x out. Y squared, y to the 5th and y to the 4th. I can take a y squared out. So remember, you take as many variables as you can out. All right, so now on the inside, I know I'm going to have 6 times 2 to get to 12, x times x to get to x squared, and I don't need any more y's in there. Minus 6 times, oh boy, 8 is 48. X is good, y squared short a little bit, so we're going to have y cubed in there to get to a grand total of 5. And then I'm going to add the number 1, really, because 6 times 6 is 6 times 1 is 6, and then x times x to get to x squared, and then y squared times y squared to get to y to the 4th. Again, nothing more I can do in the inside. The first two problems, we're literally just practicing GCF. Now what you got to be careful of is sometimes you can take a GCF out in other problems. Now on number 3, there is no GCF out of everything. You think maybe 4? You think maybe 2? Actually, in this case, there is a GCF out of everything. I didn't notice that before. If you look, 18, 12, 6, and 4. So here we go. There's going to be a 2 we can take out of everything. So it's a little tricky. If I take a 2 out, that would be left on the inside 9x cubed minus 6x squared plus 3x minus 2. All right, so this is actually a little goofy one. I didn't intend for this to happen, but we can go with it. We take a GCF out first, and now on the inside, we're going to do what's called the grouping method here. So to do grouping, what we have to do is we always keep the GCF going. So please don't let that confuse you. In fact, I'm going to kind of separate this problem. Just keep the 2 going along all the way to the end of the problem. Okay? So I want you to mentally think about that here. All right? But in the inside, we need to take a GCF out of this first part. So the GCF that can come out here is going to be, let's see, 9x cubed and 6x squared. Looks like a 3 can come out. And we can actually get an x squared out of that problem. So if we take a 3x squared out, that's going to leave a 3x in the first slot and just minus 2 there. Well, if you look at the next one, there's really no GCF. So what we can actually do in that case is take out just a 1. We want to think about taking out a 1. And then multiplying it by 3x minus 2, leaving that on the inside there. And then I don't know if you remember this or not, but we were looking for these two to match. And since they do, we're good. So we're going to take the GCFs from this grouping method here, and we're going to say, hey, let's put those together. Let's group those together. Weird. Okay, so 3x squared plus 1. And then on the back end, the 3x minus 2, 3x minus 2 actually just becomes one group. So I guess what I want to say here is, to avoid confusion with you, is that if you look at this problem right here, we have talked about exactly how to do a grouping problem. It was really good practice there. This would be the answer. Now, since we were doing the original problem and we took a 2 out at the beginning, we just got to keep that going along to the end. So all we got to say is that at the end of the problem, we got to put a 2 out front. So that's the whole answer right there. Okay, Moving to the next one. This is a trinomial. So here's the deal. Remember, we want to set up our framework first. So I'm going to talk you through where I look first. Where do I look first? The first place I always look is the second sign, as I've highlighted there. Since that is a plus sign, that does not, what that does mean is that both signs are going to be the same here. So I'm going to have, well, what two signs? I'll have a minus sign and a minus sign because of the minus right here. So both signs are the same because of the yellow plus here, and then I look here and they're both minus. Well, we should like that the first two slots are x and x because of x squared here. And then what we do is we pick factors of 15. It doesn't take much investigating to see that the two factors of 15 that work in this problem are 3 and 5. How do you know that? Remember, you need to FOIL. Now, I'm going to save the time of foiling right here, but if you FOIL this problem, you will get right back to the original problem. If that doesn't happen, you got to try different factors of 15, but it happens nicely there. Okay, looking at number 5 here, what we have is a plus sign in the back, so both signs are the same. Oh, then a plus sign right there, so both signs are actually going to be positive in this case. So we have x plus, factors of 22 that get me to 23. Now normally I tell you to pick factors that are close together, but I think it's pretty straightforward that we can see 22 and 1. If we FOIL here, those will get me to 23 when I combine like terms. So there's my answer for that one. It worked out really nice. GCF, GCF, GCF. Ah, GCF. Okay, it's okay to smile. It's math. You're having fun. Okay, so 6, 8, and 8. Let's take a 2 out. Let's not forget that we can take a GCF out, and we should take a GCF out. We need to take a GCF out if it's possible. Maybe if I just say GCF many times, you'll remember. Okay, GCF of 2. Now realize as I do this, I am only doing the inside now. I'm not worried about the 2. That just goes along for the ride. So with that said, I'm going to have a 3x, and I'm going to have an x in my first slots to get 3x squared. Ooh, back sign is a negative this time. That means we're going to have one of each. So I'm going to just put a plus and I'm going to put a minus, and we'll hope for the best here. Factors of 4 that are close together would be 2 and 2. So here's the deal. If I just put in all of my hints, all of my factors, all of my steps here, and then FOIL it, well, what happens when I do outside? 3x times negative 2, negative 6x. And then inside, positive 2x. Hopefully we see that we actually get negative 4x, and that's almost what we want. We want positive 4x. So remember, all we have to do that is switch the sign. So this plus here is actually going to become a minus, and that minus is going to become a plus. So if I do that and just change those two around, now I would have a positive 6x, a negative 2x, and a positive 4x, which is exactly what we want. So after the GCF is out, that's the final answer. Okay, I'm transitioning here to what we call a difference of perfect squares. So these you should really like. There's two terms. The outside and inside cancel off, and the reason is because you have a plus and you have a minus, and then you have perfect squares. So the square root of 49x squared is 7x, so that goes in the first slots. Square root of 36 is 6, and that goes in the back slots. Remember, I did check to see if there's a GCF because I'm really good, and there is no GCF there. Okay, moving along to the next one. This is so confusing, I don't know what I'm doing. Well, that is because you are not looking for a greatest common factor. If you look here, a 10 comes out of both, and then life is going to get a lot easier for you. If you take a 10 out, you have an x squared minus 10 out of that would be a 4y squared. Oh my, if we take a 10 out, we have a difference of perfect squares. So now remember, keep the 10 along for the ride. But just like the last problem, we have ourselves an x plus 2y and an x minus 2y. We have a plus and a minus because of the difference of perfect squares. And then we have the square root of x squared, which is x, square root of 4y squared, which is 2y. All right, are you ready? Who is ready? Tell me if you're ready to SDAP that signage, yo. So here we go. SDAP. What does SDAP stand for? Say it in your head right now. Ready? Same, different, always positive. All right, so this is recognition here, a difference of perfect cubes. So yes, SDAP works if you have that situation going on. So SDAP, the sign is negative, so we do the same, we do the different, and we have always positive. That's what that means there. So what's the rest of it? Well, remember x cubed, if we find the cube root of that, it's just x. So the first slot comes from the first number here, first term, x, and then we put over here that number or that term times itself, which would be x squared. The cube root of 8 is actually 2. 2 times itself is 4. So we only have one more thing to figure out, and that's the product of what we found in the first step. So x and 2 together, the product multiplication is 2x. So that's our final answer. You should start loving these, as a lot of you did. Okay, so now, sum of perfect cubes. So what we have here is a binomial times a trinomial every single time. And we're going to go with the same, different, always positive. Okay, so this problem here, 8x cubed, you actually want to get it down to 2x because that's the cube root. And then what is 2x times 2x? Well, that's 4x squared. So that goes right here. Cube root of 27 is 3. 3 times 3 is 9. And then what's 2x times 3? When we take the product of those two together, we get ourselves 6x. Okay, one last thing from Unit 10 here that I would like to go through is how to solve by factoring. So on these problems here, what we have to do, this is the key, please remember this. You have to get one side equal to 0 first. Okay, we got to do that first, and then we're going to do what we call a split and solve. So I'm going to not be able to show all my work perfectly here, but I am literally subtracting 10x from both sides. Okay, x squared and x are not like terms, so I can't put them together. But if I subtract 10x from both sides, I have 0 on the right side. Now we have to factor. It's called solve by factoring. So yes, a 5 comes out, but also an x comes out. We're doing GCF factoring here. So if I take 5x out, I'm going to have x minus 2 on the inside, and that equals 0. Well, if you remember me saying this many times, we have something times something equal to 0. So what does that mean? It means one of these somethings has to be 0. Either 5x is 0 or x minus 2 is equal to 0. So that's where we get the split and solve. And then if you divide both sides by 5 here, divide both sides by 5, you actually get 0 for one of the answers. And then if you add 2 to both sides, then you get x equals 2. All right, so on the other one, number 2 here, x squared minus 4x minus 5 equals 0. So we get the minus 5. We do minus 5 to both sides is the big thing I'm trying to get at. So, okay, so this is not a GCF factoring. There is none. But just like we practiced, this is trinomial factoring. So what we got to do is still, the whole goal is to get something times something else. So we want to factor, and this is actually not a bad one. We're going to have a plus and a minus because of the minus sign here. So x plus and x minus. And if we factor this correctly, it's actually an x minus 5 and an x plus 1 that works out. If you FOIL that to check right now, you'll see that this does work out. So what are we going to do? We're going to do our split and our solve. So we're going to have x plus 1 equals 0 or x minus 5 equals 0. So subtract 1 from both sides, x equals negative 1. Add 5 to both sides, x equals 5. So we get our two answers there. I hope this factoring helped you.